Thank you. Okay, so the wording on this is really weird. It's really just asking which of these are functions. So this is wording you will definitely see on the SOL. So just keep that in mind. Anyone want to do number 2?
We do have to do the explaining part too. Would you mind explaining it? No.
Good. You can. If not, I'll do it. You're fine. Okay. Thank you. So again, this one's asking, is it a function or not? And explain why, or how you know. And it's not because of the reason Alex put. It goes to -7 and 0 right here. Okay. Number 3. Anyone want to do that one? Lily?
Actually, cross out.
Sure. So you had 2 options for this one. You needed to get rid of one of them. It didn't matter which one. So you could have gotten rid of either this one or this one, either or. Questions on that one? And then, anyone want to do 4? The wording on that one was difficult too. Okay. So 4 is asking, if you had to put in an x value, Victoria, go ahead. What numbers could you put in that would not, what numbers couldn't you put in that wouldn't make it a function? Yes. So if you were to put any of these numbers in, then it would not be a function because then we have repeating x's going to different y values. So you can put them like this or put them least to greatest, either or. Questions on that? Okay. Before we start the notes on what we're doing today, I wanted to mention something. So as I was grading some of your tests, usually I do not compare them to the other class because you guys are different than the other class. You guys have more people, things like that. But your scores, the ones I did grade, were significantly lower than the other class. And I just want to point out a couple things that may maybe help you do better. I don't know. Things they do that I see you guys don't do. Practice, study all the time, work with each other, ask each other questions, get help from each other, actually do their work on time, because if you're doing it 2 weeks late and we've already taken the test, there's no real point in doing that. Not complain, do what I ask them to do. So keep all those things in mind. That may help you, it may not. They also come to see me more, they ask me more questions. If you need to start doing that, don't be afraid to ask questions. Everyone is allowed to ask questions, okay? Anyone have any questions about that? All right, so we're going to spend 2 days on domain and range because at first it's difficult It's not really something we've talked about before. You may have seen parts of it, but not really. And we're going to do this activity. Next class, we're going to do more notes-based stuff. So everyone should have a pink sheet of paper. Do it so that, open this little foldable that's on it. And then make sure that your Y arrow is pointing up, so whichever direction you need to move it so that your Y arrow is pointing up. Some of yours are bigger than others, some of yours aren't. It's just what happened with the paper, I don't know. Right? And then you should have 2 other papers. Find the one that has the graphs with the grid lines on it. Make sure you're writing this or doing this too. Cut out the example problem. So it says example at the top. Cut out that one. Don't glue it, but put it in the middle of your little foldable thing. So once you have cut it out and put it in the middle of your foldable thing, look back up here so I know you're ready. Kind of like last class when we were listing out domain and range and like the mapping piece. We're going to do that same thing, but now we don't have just lists of ordered pairs. Now we have graphs that we have to find the domain and range on. So when we're doing that, we're looking for the lowest and highest of both the x values and the y values. And we have to write it a specific way. It's called set builder notation, the way we're about to write it. It'll look kind of similar to how we were writing our absolute value answers, but different at the same time. Okay, so first we're going to find our domain. I'm going to say this, and then we'll actually use this. For a couple of these problems, we're going to use the foldable. If the foldable starts to get too confusing for you and you find it easier to do it without, that's fine. It is there to help you. So use it first. If you can do it without later, that's fine. If you want to keep using it, that's also fine. So we have to find the furthest point to the left and the furthest point to the right. So we're going to, yes, Ethan. The papers that went with it, look underneath it. Okay. Okay. So you're going to take your left side of the foldable, and you're going to move it all the way to your y-axis. So it looks like this. So I'm doing it on the board too, so you see what it would actually look like. I don't have the graph in this. I'm just showing you what the folding would look like. And then on the right, on the right side, we're going to put this to the furthest point the graph goes to. So it'll look kind of like this when you fold it. And we're going to count how far did this graph go to the left. So start at your y-axis, count how far did it go to the left, to the right. I think I said that backwards, sorry. Yes. Okay, on which part?
On how you folded it.
Okay, so put the left side to the y-axis. So you're going to have to look up here. Left side to the y-axis. The line in the middle. right side to the edge of the graph. So where you see that dot, put it right next to it. Hold it so it looks kind of like that. Did you get it? How far did the graph go to the left, to the, whatever this direction is? Mine and yours are different. So -4. So somewhere on your pink paper, write domain and range. Keep that in your foldable. We'll do the other side and then range in a second. When we write domain and range, it looks weird. So it's always going to start off like this, with curly brackets. And then we're going to put an X, and then a line. The line means such that. So X such that is how we would start to read this. We would put our lowest or furthest point to the left, which we found was -4. Then you're always going to use less than or equal to symbols for this. And then X again. Another less than or equal to symbol. And then we have to find the furthest point to the right. So we're going to switch sides. So take your right flat, move it all the way to your y-axis. And your left to the edge of the other side. So now it'll kind of look the same as it did before, but now on the other side. How far did this go to the right? 4 also. Sometimes the numbers are the same, sometimes they're different. It depends. 4, 2, okay. So we would put 4 at the end of that and then curly brackets. We'll do the range when we come back from lunch. But we're going to be doing the same thing. Okay, we're on the same example, but now we're doing range. So try to ignore the loudness next door. For our range, we're looking lowest to highest. So for the bottom flat, we're going to note this around on the side. So the top flat, put it at your x-axis. Hold it all the way down to your x-axis. Your bottom flat, fold to the bottom of the graph. So there'll be like a little space in between. Bless you. And we're going to count how far down did the graph go. Cameron?
Is that
-1. Yep, it went down 1, down to -1. Yep. So when we start writing our range, it's going to look very similar to our domain, bless you. But because range is y, it's going to be curly bracket y, the line, such that.
Okay, did we write this on the pink paper?
Yes,
Or
on the pink paper.
for now?
Our lowest value was -1, so we're going to put that is less than or equal to. But now we're going to use y in the middle instead. Is less than or equal to. Now we have to find the highest. So flip your flaps. Sure. Now put your bottom flap on your x-axis. and your top flap at the top of the graph. And count how far did your graph go up.
Wait, what did you
Say that part one more time. Put the bottom flap to the x-axis, and the top flap to the top of the graph. How far up does it go, Christian?
8.
Sometimes the numbers will match, like negative and positive. Sometimes they won't. It just depends on the function. And then we would end with a curly bracket. Lily.
for the greater than the equal to
The less than
or
or
equal to, it doesn't matter like which, like if it's less than or greater than or less than.
For these, we're always going to use less than. The only time we use greater than, you'll see those examples. Great. Other questions so far? Yes.
What's the purpose of the greater than something?
So this is saying all of your x values lie between -4 and 4. We don't want to list every single number in between that, because that would be not just the whole numbers, but all the decimals and fractions too. So this is a way to say that without putting every single number. Okay. Any other questions? Take that graph out of your foldable, glue it somewhere near your domain and range, and cut out number 1. And put number 1 in your foldable.
I knew it was good.
Okay, you can go that one way. Alright, so let's talk about the domain again. And remember, as you get more comfortable with this, if you can look at the graph and not use the foldable, that's fine. We'll just use the foldable a couple more times, and then if you feel comfortable not using it, that's fine. Okay, so let's find our furthest point to the left. So you'd be, holding your left flap to the y-axis, your right flap to the furthest point on the left side. How far to the left does this go? Really? I believe it's -7, but yeah, I believe it's right. So somewhere else on your pink paper, if you didn't already, write domain and range. And then it's going to start off the same. Your curly bracket, your x, your line means such that lowest point to the left, or furthest point to the left, is your -7. Less than or equal to x, which is less than or equal to, some of you may have already started to find the furthest point to the right, but if not, go ahead and do that. What is our furthest point to the right? Just being positive 7. And again, sometimes the numbers are the same, sometimes they're different, so don't assume it to be the opposite. Make sure you count. And then end it with your curly bracket. Now, for the range, we don't need to use our flaps because is it moving at all? Is it going up and down? No, it's at just one place the entire time. So we can say that y equals wherever it's at. Where is it at? Hannah? 3. So we would write that similarly, curly brackets, y, our line, but then we would just put y equals 3, and that's it. This is just a line. Okay. It's just part of the notation. I didn't make this notation. And then glue that graph somewhere near your domain and range. I lost my little sticky note. Okay, we're going to do example 2 next. So you can cut that one out. If you would like to try to do this one without the foldable, you can. I'll let that be a you decision, and I'll talk you through kind of how you would do that. Lisa, did you cut out the next one? We're on number 2 now. Ethan, make sure you're cutting this one out. Somewhere on your paper, write your domain and range. If you wanted to try to maybe stop depending on the foldable, you would have to ask yourself these questions. For your domain, you're looking at the furthest point to the left and the furthest point to the right. So you would have to look at it and figure out what those things are and then put it in the set building notation. For range, we're looking at the lowest point and the highest point. So I'm going to ask these questions, whether you use the foldable or not is up to you. What would the furthest point to the left be? Victoria? I believe that is correct. Before I start writing, I'm also going to ask for the highest point so we can write it all together. Or I'm sorry, the furthest point to the left, or right. Furthest point to the right, because we just found that. What is the furthest point to the right? Say that again. I believe that is also correct. If the graphs are a little hard to see, which on these sometimes they are, you can outline your x and y axis. That might help you some. So if our furthest point to the left is -6 and our furthest point to the right is +6, how would we start writing this? Lily? No. Okay. Anyone want to take a guess how we would start writing this nature? Mm-hmm. Such that? Mm-hmm.
Less than or equal to x. Less than or equal to 6.
Yep, just like that. So once you get the format down, then you're like, okay, I can write this all the time. It's just, you have to get used to the format. Questions on domain? Let's find the range. So now we're looking at lowest to highest. What is our lowest point of this graph? -3, I believe that's right. Yep. And our highest point? Sophia? 3. So how would we start writing our range? Lily? Just like that. Questions on the range? After you have that written down, go ahead and glue that, and then we're going to skip a couple. Cut out number 5. Yes. Go ahead and make it fast. Once you have number 5 cut out, find your your furthest point to the left. What is your furthest point to the left? Nature? Okay. What is your furthest point to the right? Did you do the best? Okay. Iman? 4. So we would write our domain like what? How would we write our domain? Our furthest point to the left was -4. Furthest point to the right was +4. How would we write that? This was for 2, not 5, just so we're all aware. Lily? I'll scroll back down if you miss that. For our range, what is our lowest point? -7. And then our highest point? Hannah? 7. So how would we write that range? Elisa? Less than or equal to, but yes. Right. Imam? As soon as Izzy gets back, yes. I didn't see it, and it'll cancel. So as soon as it gets back, sure. Right? Questions on this? Flip your pink paper over, and we're going to go to the other page. Cut out the example. You can go ahead and glue the example on the back of your pink sheet, or it should be the side you're on now. Right domain and range, somewhere around it. Before we actually find the domain and range, what do we notice that's different here? There's no grid lines, sure. Alice? So there is something else that's different. There are no grid lines and Destiny? There are arrows instead of endpoints. So that's going to play a huge difference in how we write our set builder notation. So for our domain of these, you kind of have to think outside of the box a little bit. You have to imagine this, picture it. For this is going to keep going up and left, off the page, off the smartboard, forever and ever in that direction. Imagine that it's doing that. Because it has the arrows. This is going to do the same thing, keep going up and right, off the page, off the smartboard, forever and ever in that direction. Imagine that. If it goes in both directions, so left and right, then we write it a specific way. Still the curly brackets with the line, X such that. But it's saying it's going from negative infinity, which is where it would go eventually, to positive infinity. So all of your numbers that you know of are included. So we would write it like this. X with a weird E with a weird R. This means X is an element of all real numbers or all real numbers. This means this goes left and right, both directions. If it doesn't go in both directions, we can't say it's all real numbers. Before we do range, what questions do we have on that one? Range is easier to see because you can clearly see that this is pointing up. Domain you have to kind of think about, imagine what would happen if it kept going. So range, I see that this keeps going up. It does not go down. So because it doesn't go both, it can't be all real numbers. So I can talk about the lowest of this and the highest. The lowest part of this starts at your x-axis. What is your y value on your x-axis? Nature? Mm-hmm. So we know it starts at 0 and then it keeps going up. If you were to ask what's your highest point, and because it keeps going up, we could say we don't know, then it's going to go towards infinity. I can say that this function is everything above 0, so it would be everything greater than or equal to 0. This is where we would use greater than instead of less than, but it depends on the problem. Do we have questions on the range? Lily.
Is it only going to be that answer, or are there going to be like certain numbers?
You like different examples, you mean?
Like if it was a different example, would there be like numbers like for the R? Would there be a number?
No. So this will just be these three. Letter E, R. This could be wherever it is. It depends. Okay. Other questions on that one? After you've written that down, cut out example number 1. You want to write your class? You're going to make sure you put your phone back. The first one, yep. You can also go ahead and do that one. Write domain and range somewhere around it. Look back up here so I know that you're ready. For our domain, again, you have to imagine it, think that this is happening. If I ask you what the furthest point to the left is, because of the arrows, this is going to keep going down, yes, but also slowly out to the left. It's like going to keep doing that. As it's moving down, it's also moving to the left. You have to imagine that it's doing that. And then same thing to the right. If I ask what the furthest point to the right is, it's going to keep going slowly slowly up and out to the right. So if it's going both left and right, that's going to be another case of all real numbers. So we would write it the same way. X such that X is an element of all real numbers is how that's read. Or the shorter version, all real numbers. For our range, if I ask you what the lowest point is, do you know what the lowest point is? What about the highest point? No. So if it keeps going down and up, what would that be? Victoria? Greater than what? Okay, so part of this is y is greater than 0, yes, but it's also going down. So it wouldn't be that. If it's going in both directions, what does that mean? Hannah? All real numbers. It just looks different. So we have our curly brackets, y such that y is an element of all real numbers. So anytime you see arrows going in both directions, left and right, except I did that backwards, up and down, that's all real numbers. But if it just goes in one direction, then it's not all real numbers. So if it just goes to the right or just goes to the left or down or up, then it's not all real numbers. Questions on that one? We're going to do 2 more examples together, then you'll have time to practice on your own. So cut out number 2. Okay. In each of these problems, it doesn't matter if you do the domain or range first. If you find one easier to do than the other, that's fine. Go with that. I just happen to always do the domain first. Okay. For our domain, what is our furthest point to the left? Do we know what our furthest point to the left is? No. What about our furthest point to the right? At 1, so this is at 0, 1. I'm assuming 1 would be somewhere here or it could be there. Is that the furthest it goes? Or does it go past that? It goes past that, so it's not 1. Do we know our furthest point to the right? No. So also remember, imagine that this is going down and out slowly, and down and out slowly. So what would our domain be? Really? A lot of these are going to have that as an answer. So how would we write that? Nature. X first, then E. Yep. So when I do my R, I just make a capital R and draw another line through it. As long as it looks like a double R, you're good. The E, as long as it looks kind of like a backwards 3, you're good. I said a backwards 3. That's basically what it is. Yeah, this because of the line next to it. If I pulled up an actual R that I didn't just write, it would look more fancy. I just can't do it as fancy as it's supposed to look. Alright, range. What is our lowest point? Do we know what it is? No. What about our highest point? 1. So make sure you're looking at your y value, not your x value. It does not go past this. So if your highest point is 1, that means everything else is below it. So would that be less than or greater than if everything is below it? Less than. So curly brackets, y such that y is less than or equal to 1. Number 3 will be our last example we do together. you get that glue down, look at your domain. What do we think our domain is going to be? What do we think? We're looking at our domain, furthest point to the left, furthest point to the right. What do we think our domain is going to be? Nature? Mm-hmm. Keeps going left, keeps going right, so that tells you all real numbers. Your range is like the one we did on the other side that had this straight line. Is your range moving? No. So it's going to be a y equals. What would your y equal? 1. So curly brackets y such that y equals 1. Right. So I want you to finish the rest of these except for numbers 8 and 9. You do not have to do those two. I'm going to write what they are up here. If you would like to write your domain and range on the paper itself and then just cut that out and glue it on your paper, you can do that. If you still want to write it, that's fine. So you only do 8 and 9 if you want to, but I'm going to write it up here. Do the rest of them. You guys can work together, move around. Make sure you are actively working. And let me know if you need my help, have any questions, want me to check over anything. Hold on 1 second.